Hello everyone, in this video let's discuss about Codable protocol, which is a type alias for decodable and encodable protocol. So it is like this, it is a combination of two protocols. So it's just kind of like an interface aggregation principles where sometimes we need to decode our Swift pretty much what is this decodable and encodable. So in this tutorial let's discuss more in detail into decodable and encodable protocols. So before we start that, let's discuss something called JSON serialization, which we used to do before Swift. In earlier versions of Swift, we used to do this JSON serialization pretty much before Swift 4. Swift 4 has changed this totally by introducing Codable protocols. Codable protocol is the composition of decodable and encodable protocols. So what is this JSON serialization actually? JSON serialization is a class in Swift Foundation framework that provides methods to convert between JSON data and fundamental objects like dictionaries and arrays. So here if I call it as there is something called serialization and deserialization as well. So if we see serialization is nothing but Swift type 2 JSON data, Swift object, I would say. Swift object could be a dictionary or an array. So Swift object to JSON data is, we call it as serialization, and in the same way, so deserialization in the sense JSON data to Swift object. So we can convert a Swift dictionary or array which contains only foundation types actually into JSON data using only the foundation types into the JSON data using the JSON serialization. So pretty much JSON serialization, I have made the code ready so that we can save some time in this tutorial. So for example, this is the Swift dictionary, which is nothing but a Swift object which is of dictionary. It is having key value pairs. So this is how we can use the JSON serialization. Is the native is a class which is there in the Swift Foundation framework that provides methods to convert from JSON to JSON data to foundation objects like dictionaries and arrays. So this is serialization pretty much, where our Swift dictionary is getting converted to JSON data. So JSON serialization dot data with JSON object this is how we used to do when there before Swift 4. After Swift starting from Swift 4, we have Codable protocol. So our life becoming easy now. So because of Codable protocol, earlier we used to do like this, and again JSON string to this is the JSON string. Usually this is how we get it from the API responses. This we can convert it as Swift objects. That means this is converted as a dictionary actually. So this is Swift object to JSON data, and this is JSON data to Swift object. So this we call it as serialization and deserialization. Why? Because Swift object to JSON data is needed when we want to send it to the API, and when we are getting something from the API response, we want to convert it into Swift object. So that is the reason we had to use JSON serialization, but technically there are some challenges with this JSON serialization, which is nothing but when dealing with more complex JSON structures or custom objects. So this is a very simple JSON structure, this is a very simple custom object. When dealing with more complex, that means for example, so like this, so this is having custom object, custom objects also we can convert it using serialization and deserialization. So this is straightforward simple JSON object. But whereas when dealing with a more complex JSON structures like this, for example, it is having ID, username, email, within which there is a nested structure which is called address. Using JSON serialization directly can become complex and error prone for few reasons. Why? Because if I need to do from this to this, that means if I need to do deserialization, then this is what I need to do. See, I need to convert it into the JSON data to JSON object, which is nothing but the dictionary of ID, dictionary of key names, dictionary of address, city, zip code, and as it is a nested structure, I need to take address dictionary. Again, it is having 3 key value pairs. Now if it is a nested structure, see the amount of code that we need to write. So if your JSON data contains nested dictionaries or arrays, you would need to manually traverse and extract data at each level, which can lead to nested loops and more complex code. And the typecasting, when deserializing JSON data using JSON serialization, also we need to explicitly cast values there to their expected types. This is how. This typecasting can become cumbersome, especially if our JSON structure is deep and contains a variety of values. So I just added an address inside of a person class. Now see the amount of code that we had to write. So error handling is also very difficult. JSON serialization doesn't give any proper error handling. If there is something is missing, it doesn't usually give any proper error handling. And maintaining such, so as our JSON structure evolves, or if you introduce changes to your custom object, suppose here all of a sudden if I add something like country, then again I need to traverse and I need to add so much piece of code, which is maintaining this also is very difficult. And for example, let's assume I have data transformations. For example, such as converting dates, enums or custom types. So then we would need to perform these transformations manually during serialization and deserialization. Manual mapping for custom objects, we would need to manually map JSON keys to object properties, for example like this for custom objects. So like this we need to manually map. So there are some issues with definitely with the JSON serialization. We don't want to, it's very difficult. Earlier we used to face these challenges. So if I have to, it's if we have nested JSONs, then it will be a problem. And nested structures, nested JSONs of nested structures, I would say. Next one is, for example, typecasting. Of course we have seen, if I have to typecast each and everything, looking at, for example, if this age is int, or for example if this address is of type address, or it could be if it is a dictionary or array, then it's very difficult for me to typecasting. When deserializing JSON data using JSON serialization, so we need to explicitly cast values to their expected types, which can become cumbersome. And manually we need to map. Manual mapping is one thing. For custom objects, we need to manually map JSON keys to object properties, which can be error prone. Why? Because we are going with the key value pairs, which has nothing but the strings. So this may go wrong. This may go wrong. This may go wrong. So mapping is also manual mapping is, of course, it's not safe. And error handling, of course, we know that it will not give, if something goes wrong in a big nested structure, then error handling using the JSON serialization is very difficult. Next, data transformations. Of course, for example, I am getting let's say for example date conversion. For example, I am getting dd YYY from the service. If I need to do date transformations like YYY or something like this, something, or DDD or something like this, DD YYY. So if I need to display these data transformations, if our custom objects are having non-trivial data transformations such as converting dates, enums or custom types, so we would need to perform these transformations manually, which is code using those protocols. I think it's very easy, we'll discuss that. But here data transformations is, of course, at the end, because of all these maintainability. So as our JSON structure evolves, or if we introduce changes to our custom objects, imagine we are introducing a change in for example custom objects, or a change in our custom object, anything that will result in so we will need to manually update our serialization and deserialization code accordingly. This can be time consuming and error prone, obviously. So Swift, this is actually the JSON serialization. As you can see, converting Swift object dictionary or array to JSON data, and this is generally we do this when we are sending something to the API, or if we want to save something in the device. in the app bundle. So the serialization we do it so that we can save it in a file format. Whereas or if you are getting if we need to send something to the API, so Swift format we can't send it to the API, so it has to be converted to JSON string. For that, first it has to be converted to JSON data. Deserialization, again JSON data to Swift object type. This we need it when we get the response from the API object or API response, or when user opens the app again. So whatever the serialized data, if you need to deserialize it, we convert it from JSON data to Swift custom type. So for this we used to have JSON serialization, which is part of foundation framework. This gives the methods which are needed from, such as for serialization data, for deserialization JSON object. So and these are the disadvantages. Your code will become very cumbersome and it's very difficult to maintain this piece of code. For this reason, Swift's Codable protocol addresses these challenges by automating much of the serialization and deserialization process. So how it does, and how we can use codable and decodable protocol is pretty much we discuss in this video tutorial. So we discussed serialization. Now we have seen what we do with the serialization, what does it mean by serialization, deserialization, what are the disadvantages. Now problem, solution. What is the solution? Codable, decodable. Okay, how come it is nested also we discussed. These are the challenges actually. Just for an example of taken nested JSON, nested structure. So we have seen this. Now okay, now I come to the solution part, which is Codable Swift 4 introduced it. This starts from Swift 4. Codable is nothing but decodable and encodable. It is a type alias. So pretty much almost every app has its own user data that has to be saved when the user closes an app and still exists when the app will be opened the next time. So to do so, that's the reason we use the serialize. We need to do the serialization and deserialization. The info that lives in memory must be encoded to a form of data that can be written to a file. That's we call it as the serialization. So the Codable protocol makes it possible by creating a key value pair from our object's property names and holding it that can be used by an encoder or decoder object. So how to do that, use if we have, for example, let's take the same solution. For example, let's say this is my JSON. Okay, so I'll take for the same JSON, let's say this is my JSON. Let's say this is the problem in JSON serialization. So I'll take it as codable JSON string. So how this problem can be solved by using the Codable protocol. We see, for example, this is the API response codable JSON string. Now what first we need to do is we need to write models, codable models for the given JSON schema. It's very simple. Is for example, so whether to take a structure or class, depending on what, there is an Apple documentation when to choose a structure, when to choose a class. This is out of scope for this tutorial, but for now I am taking it as struct. Why? Because my data is, so I take it as user info. This is my user info. Now user info is having ID which is of type int. This is how we need to write the models first to play with the Codable protocol. I think some tools or some pods are already available, so that giving the JSON, they will already automatically give you the Swift structures or classes based on that. We can use that, but I just want to have at least I suggest to know the process of how even they create it. Let's say username is of type string. Next let email is also of type string. Now the address is a dictionary, but we are native primitive types. We are not going with dictionary and classes, we are going with our custom object. So we need to have address. Again it is having street string, and what else, city, this zip code, this. Now then I can put like let address. Okay, now if I have to now how can I convert this into this, correct? Now that's the reason we have JSON decoder, and for decoding, let's talk about only the decoding for now. So that means I am first discussing the decodable, let's say. So first let me discuss decodable, for which we have JSONDecoder. That means how to do it is, let decoder is equal to JSON, JSONDecoder. Next, let user info is equal to, it's always try. Why? Because try decoder dot decode is, it is expecting a type here. So what we want, end of the day, it is our user info dot self. This my type is this from data, so it is nothing but a JSON data, but unfortunately we are having the JSON string. First we need to convert JSON string to JSON data, for which we know how to convert that. For example, see again, if JSON data is equal to, which is nothing but user info data is equal to, we have JSON dot data using of course UTF-8 we do. If we have that, then we can do this, but this is a try, so it is this. Let's try now. Catch, in the catch I'll just catch it and I'll print it. So catch default argument is error. Okay, so this is my decoded. That means this I am converting it to this. That means deserialization I am talking about first. This is nothing but deserialization, a JSON data to Swift type. This is what I am trying to convert using the JSON decoder. We already have decode is what we get, and from the JSON data is user info data. Now once we get it, we print it. That means whether, just to check it, user info dot, okay, just the user info. Now let's run it and see. It is trying something, saying that instance method decode requires user info conform to decodable protocol. That's what I'm saying. So we need to use the decodable protocol, then only decodable, then only you can pass this type. Okay, type user info does not conform to the protocol. Why? Because when you're saying decodable, everything should be convertible to decodable, but address is not decodable. Again, you need to go, it's as simple as that. You put the protocol, you confirm your custom object, your custom object should conform to the decodable protocol. Then see, it stop giving the warning. Now if I run it, perfect, this is my user info object. See, from JSON string I am able to convert it into my Swift custom type user info object. ID, username, example, address also, if you can see the address object got created, and I have got my perfect Swift type from the API response or from the JSON using the deserialization process, which is using the decodable protocol with the help of JSONDecoder. JSONDecoder pretty much gives us the decode where we pass the type. That means which type you want from which data. That means this is okay, this is your JSON data, what is your type, tell me. If you are giving this type, boss, you need to convert, this needs to conform to decodable protocol, then only this works, otherwise this fail. Now error, okay, we thought like we discussed like JSON serialization, error parsing, error handling is very difficult. Now how come in the Codable it becomes very easy? Now let's say for example, let's say it is zip code here, Now if I go here and only mention zip, now let's see what happens. Gone. It is saying key not found. See, coding key string value zip was zip. Something you got no value associated with the coding key string value zip. That means you got some information saying zip may in the zip you are having some, in the zip code you are having some discrepancy, which is nothing but here it is zip code, but here you have used it as zip. So this and this should be same, otherwise it will start complaining. Now yes, now you got it right. So see, it is clearly giving that in the decoding there is an error, there is a key which is not found, which is nothing but zip, decoding error. So that's the benefit of using decodable. Why? Because it clearly says what went wrong in decoding. Okay, and in the same way, so let's discuss in the same way we had in this. Let's discuss. We have something called JSON encoder, and you need to convert to encodable protocol, which is nothing but the serialization. That means my Swift custom type. That means let me take an address something, sorry, not from decoder, address I would need from city, state. So I'll give some value, I'm not city, some value, zip code, some value I have given. Now let user info, I'll give something. This is my object. Now this I need to serialize it. That means I need to convert it into a form where I can save it to the file, or which in the format which I can send it to the service call. Okay, so username something, email something, address, again I have the address object. Okay, this is my object. This I want to serialize it, serialization. That means I need to encode it. Now again the same process that applies. Here we have taken the decoder, now I take the encoder. Okay, JSONEncoder. Now I'm encoding it. That means encoder let user info data. That means Swift to type to JSON data for API. Let's say for API, let's say is equal to try. Again this is also try, encoder dot encode. What is the value? Value is user info dot self. So this, let's say user info for API, so that will not have any duplicates. This is user info API dot self. Now again it is completing what it is complaining, saying instead method encode requests that user info conform to the encodable. Oh, okay, it is confirming to decodable. Now it has to conform to encodable as well. Correct? Decoding we are able to do encode. Now again it is the same thing. The type user info does not conform to the protocol, but it is conforming to the protocol, but address is not conforming to the protocol. Now again I go and say like encodable. Now perfect, I should not be getting any error now. Okay, since it is a try, let me go with do try catch. Okay, sorry, now I have got my JSON data, but end of the day I need to convert it into what a string. User if let user info string for API. Let's say I need to send it as a body, string body or something like that. So we have something called string in it, and since this is data, this is my data. Why? Because from my Swift type to JSON data I converted. Of course the same UTF-8 conversion we get it, and if there is an error, you in the process of encoding, what we are saying is okay, you catch. Now you pretty much print the error if you feel like there is if it gives an error. Now here I just print user info string for API. Correct? Okay, now let's run and see. Yes, a beautiful string got formed, user info string for API. See, from the values which I have given, it generated this again back to looks like serialization. That means encoding. This is the in this form only we can encode it. See, it converted. Sorry, let me run it again. Sorry. See, in this form, street address is, so in this format only it has come. So I serialized it, that means I encoded it from my Swift custom type to JSON string type. So this is the serialization. I used a JSON encoder. I have JSON encoder which I can encode, I can decode, for which they have to, for encoding and decoding, if I have to give this object type or this, they have to conform to decodable and encodable protocols, which again, if I give something like, just a second, if I give like if I change it, if in the encoding process also if there are any issues, then pretty much you get the same error, it catches and you can see that error pretty much. So that's basically encodable and encodable and decodable protocol. So since we have a type alias, this I can replace it and put it as codable, and this I can replace it as codable. So same, no issues. See, it's how convert. So for example, every time we don't need to serialize it, only deserialization works, but every time, sometimes only the deserialization is enough. Serialization is not required, sometimes serialization is required, deserialization is not required, correct? Not every time we send the data to API, every time we, most of the time we get the data from the API, then what we need to do, we need to deserialize it. That means the JSON that is coming from the service to the Swift type. So, but deserialization, I think decodable, decoding what API is giving, decodable is enough. If you need only decodable, you can go with decodable. But if you are doing both decoding and encoding, I think codable type alias we can pretty much use. So pretty much that's how codable protocol being introduced in Swift 4 is helping us and making our lives very easier with respect to serialization and deserialization, so that we can, this is how we can write the models for the JSON schema, and we can play with codable and decodable and see the lines of code here. It's pretty simple. It's pretty simple compared to the tons and tons of code even for a simple nested structure. Here you can have any nested structure. If you inside it, if you have anything, another structure will come, another model will come, and again it's same. Everything should be should conform to the so and so protocol, and JSON encoder and decoder makes our life very easy. So that's the pretty much usefulness of codable and decodable, and that's all for this video tutorial. Here we are having few more topics like what if I want to encode and decode manually. For example, here automatically encode and decoding are getting happen. What if I want to manually do it? That means if my JSON schema, for example, in my object, for example, zip code, if I change it to zip, it was giving me an error. For example, I don't want the zip code, I want zip. For example, I don't want it like username, I want it like uname. I don't want it like address, I want it like email, I want it like mail or something like that. If I want to change the structure, that means key names, that we have something called coding keys, and also we have something called additional keys, and also this data transformation. So how we can do in using the codable and decodable protocol. And also actually if we are manually doing, codable comes with decodable comes with this actually. So when to use, here we are not using it, we are automatically doing the encoding and decoding. How to use this decoder and encoder init methods, and if it is encodable, it's like func encode to encoder. So this is automatic encoding and decoding, but this is manual encoding and decoding. For example, if I want to override the encoding process, that means instead of directly giving the zip code or instead of directly giving the city, if I want to add manipulate any data, that means I don't want to directly I mean to say my zip code should not be having the string, my zip code should be having integer value. So that means this data transformation I am talking about, correct? So I want to convert this string to obviously integer. So in this case, how to use the, so I need to manually do the encoding and decoding process in this case. Why? Because to support my functionality. So how we can do that and how it can be done easily is something we'll discuss in our part 2 tutorial of Codable protocol. I think for now we learnt a lot: serialization, deserialization, using the JSON serialization earlier, what are the disadvantages of it, how it is very difficult to maintain it if it is even having a single nested structure. See the piece of code that is there, we have to write for the serialization and deserialization using the JSON serialization, lots of code. But how decodable and encodable made it very easy. See the lines of code, it's very simple, it just encode, it just decode. Only thing is they have to conform to codable or decodable respective protocols. I hope this post is useful. See you all in the next tutorial of this Codable protocol, where we will discuss mostly this coding keys. What is it? Coding keys, how I can make my custom object, custom keys, additional keys, how we can do the data transformations, how I can manually download it. We will discuss in our part 2 tutorial. Thank you.